Hello, everybody, and thank you very much for having me. I'm glad I can give my contribution to this conference. So, yeah, as Katerina said, I am a PhD student working at VSL, and I am part of the Dendrosciences group, working mainly with tree rings in relation to atmospheric particulate matter, but not only. For my PhD research, my supervisor, Paolo Cherubini, and I collaborate with many researchers from different affiliations, as you can see, and together we conducted a novel experiment where we investigated the uptake and transport of particles of nanoscale in trees, which I will show you later on. Today, I wish to answer this question: can trees be used in monitoring atmospheric fine particulate, and explore what it is known so far. We already see 3 or 4 keywords, so trees, monitoring, atmospheric fine particulate, and I would like to start investigating these topics. I will start by saying a few words about air pollution, as it is the major environmental risk, not only to human health, but also on various components of different ecosystems, such as plants and animals, because of the increasing industrial activities and population growth. From the data collected by the World Health Organization, we see around 7 million deaths every year due to outdoor and indoor air pollution. The parts of the world that count more deaths are located in Southeast Asia and Western Pacific. Air pollution comprises variable quantities of many different types of pollutants, including gaseous and solid pollutants. The main air pollutants are sulfur dioxide and heavy metals, both coming from the consumption of fossil fuels, nitrogen oxides from road transport, industry, and energy production, which also contributes to the formation of the ozone and particulate matter. Ammoniac is another pollutant that comes from the use of organic or mineral fertilizer in agriculture. And we have volatile organic compounds that are naturally emitted by vegetation. But they also come from industry and paintings, and they contribute to the formation of ozone under the action of the sun. Depending on the nature of these air pollutants, the interaction between them and the plants can be different. As you can see here from this picture, particulate pollutants, organic or inorganic, are first captured by foliar surfaces thanks to the microstructure created by the presence of epicuticular waxes or trichomes or hair present on the surface of the leaf, and they generally are between 1 and 10 microns in size. Also, the influence of meteorological conditions such as wind, sun, and rain, and the structure of the leaf play an important role. There can be leaching or resuspension of the particles in leaf decomposition, which can then reposit the particulates on land. Thus, vegetation can act as a transactional step towards the soil. In that case, pollutants can potentially be uptaken by the roots, but I will not speak about this aspect, as I will mainly focus on the leaves. In the case of gaseous pollutants, depending on their molecular weight, they could penetrate into the stomata or be trapped in epicuticular waxes. Let's go more into details and focus on the atmospheric particulate matter. It is defined as a mixture of solid particles and liquid droplets in the air. They are either directly emitted in the atmosphere, like for example, burnt fuel or wind dust, or they form from other gaseous pollutants, which turn into particulate matter. Based on the size, particulate matter is often divided into two main groups. We can take as a reference for the scale dimension the fine beach sand and human hair. And we have the coarse fraction that contains larger particles from 2.5 to 10 microns, like pollen, dust, or mold, and the fine fraction, which contains smaller particles up to 2.5 microns. The particles in the fine fraction, which are not represented in the image, can be smaller than 0.1 microns, and they're called ultrafine particles. In this category, we find the particles at nanoscale, called nanoparticles, which I will introduce to you later. Many studies have been conducted in urban environments to investigate the role of trees in the mitigation of atmospheric particulate matter and improvement of the air quality. Most important is the road traffic, which is a dominant source of air pollution in urban areas globally. Especially in the near road environments, vegetation can act as a barrier between traffic emissions and pedestrians by collecting pollutants or redirecting the flow of polluted air. Here, I want to propose 3 different studies conducted in different cities where the particle capture efficiency of different tree species was calculated. All 3 studies confirm that conifer species have the highest capture efficiency, whereas broadleaf species have only able to capture small amount of particles. And the reason lays in the type of the leaf and its structure. Conifer species have a more complex leaf structure, and their small leaf size and wax layer is more suitable for particle deposition. But among the broadleaf species, low leaf wettability, leaf hairiness, and low stomatal density contribute to higher particle capture. In this table, I want to show you a list of some non-native tree species that could be more suitable to be planted in urban environments because they are considered to be effective for air pollution abatement. And this is based either upon experimental findings, an exhibition of beneficial traits, or a combination of both. All of these species have low emissions of volatile organic compounds, which we saw they can contribute to the formation of ozone, and low emission of pollen, which is also part of the particulate matter. The data that are included in this table comes from a document that was issued by Kumal et al. From the Center of Clean Air Research of the University of Surrey in the UK. As you can see, in the case of the stone pine, its choice can even be a more compact option than using a native species such as Pinus sylvestris. Of course, as we are speaking about non-native trees, there is the risk of invasive species that has to be considered in the case of false acacia or the staghorn sumac. But overall, all these species have a dense canopy and good drought and salt tolerance to survive the urban environment. As we saw earlier, that it's one of the main causes of stress on urban trees. Now, I mainly referred to the deposition of particles on the leaf surface, but what happens if the gaseous pollutants penetrate into the leaves? And the second question, what if the particles are small enough to penetrate the leaf? Let's answer the first question. The penetration of the pollutants into plants is mainly through the leaves. There are also some that can penetrate through the stems or the trunk. Before reaching the leaf, the pollutants can first have to pass through the boundary layer, which is this part here, that corresponds to the layer of air not agitated in contact with it. The thickness of this layer depends on the size and the shape of the leaf, and the presence of leaf hairs, and also the wind speed. The incident pollutant, such as these, can react with the water film present on the surface of the leaf, with the lipid phase that consists on waxes present within or located on the surface of the cuticle, and then they can interact with a gaseous phase consistent on the components of the atmosphere and the emission of the leaves. The pollutants then mainly enter through the stomata present on the leaf surfaces, but a large part of the organic pollutants will also be absorbed mainly by the lipid structure of the cuticle. Of course, plants can have also mechanisms of defense. They can limit the absorption of the pollutant or increase their tolerance. And this can be done by physical processes or biochemical processes. And of course, all of this can result in a stress condition. Many studies, as the ones you can see here, show that pollutant concentration, mainly heavy metals, can be measured in different tree components, such as leaves, branches, or bark of different species all over the world, but also in tree rings. And not only heavy metals, but also gaseous pollutants were found in the tree rings, as Sauer et al. Showed in their paper. It is important because if heavy metals can be taken up by trees, either by the leaves, but also by the roots, gaseous pollutants are most likely to enter in the leaves and be transported through the phloem to the wood, and then stored in the tree rings. And this said, I want to introduce the topic of dendrochemistry, which is the science that examines the chemical concentration in the tree rings. It is thus possible to investigate the air pollution, the groundwater contamination, or the soil contamination, whose signal can be found in the tree rings. And this is because, as you might know, trees are influenced by the physical and chemical conditions of the environment they grow in. So therefore, they can act as a natural bioconcentrators of air pollutants. Tree components, such as leaves and bark, can be used to determine the spatial variation of the atmospheric pollution in a region, but tree rings give us more information about the historical variation of the pollutants. As you can see here in this example from Odabas et al., that they show the concentration of lead in tree rings throughout the years. And its concentration in the tree rings, it's getting higher when the number of industries is growing. Very interesting. And now we can answer the second question. And to do that, I want to introduce the topic of nanoparticles. So, which are particles that range from 1 to 100 nanometers. Nanoparticles can have natural origins. They can come from lunar dust, from volcanoes, or mineral dust. They are incidental as a byproduct of industrial processes, and then engineer nanoparticles, which are produced in the laboratory. And from now on, I will refer to the engineered nanoparticles. The field of application is very wide. The nanoparticles that are used in agriculture are for delivery of pesticides, fertilizers, or phytoremediation, but they can be also discharged into the terrestrial and aquatic ecosystems, and thus bringing negative effects to the environment. And that depends on the nature and the concentration of the nanoparticles. The literature is rich in reviews about nanoparticles in plants in general. Several studies related to annual plants, but mainly crop plants, directly connected to the human health, but few studies about nanoparticles in trees. And here lays a research gap. That is, the effect of trees, of fine particles at nanoscale is still largely unknown, and their presence in trees is poorly understood. A few words about nanoparticles in plants. The uptake and translocation and accumulation of nanoparticles depend on their chemical composition, on their concentration, size, and dimension. And you can see how various that is, but also on the chemical and physical properties of the plant species. And there are two pathways for the delivery of the nanoparticles in the plant system, from the root to the shoot, the xylem, or from the leaves to the roots through the phloem. Nanoparticles can into the plant cell through many mechanisms which are not clear yet, and there are contrasting theories. I want to bring to your attention the study by Cocotte et al., one of the first, if not the first, to investigate the uptake of nanoparticles in trees. They conducted an experiment with 3-year-old species of Quercus pubescens, Populus nigra, and Pinus sylvestris, which they contaminated with silver nanoparticles, spraying their leaves or giving it to the roots through the soil. And their results showed that the uptake of the nanoparticles was species-specific, with the poplar that had the highest amount of silver nanoparticles in both leaf and root supply. And also the highest amount of silver in the stem of the plants from the leaf supply, as you can see here, brought authors to the conclusion that in their experiment, the silver nanoparticles enter the tree stem faster through the leaves than through the roots. And on the basis of the study, we conducted the greenhouse experiment I was mentioning at the beginning of my presentation. We did that at VSL, and the project was financed by the Swiss National Foundation. We investigated the phase of gold nanoparticles taken up by trees through leaf and root pathways. Our main objective was to better understand the uptake and transport of nanoparticles in trees, especially in this case of gold nanoparticles, and see if they mainly enter through the roots or through the leaves. We also wanted to investigate the influence of the surface charge on the uptake and transport of these nanoparticles. And we worked with 2-year-old species of Pinus sylvestris and Fagus sylvatica, and we sprayed 40 nanometer gold nanoparticles of 3 different surface charge on the leaves, and we gave them hydroponically to the roots. The time of exposure was around 24 hours, and after 20 days, we harvested the plants. Here I want to show you the first preliminary results, as we are not done with the analysis yet. But you can see that in the leaf supply, the gold is higher in the leaves and in the stem than in the roots, whereas in the root supply, the gold was found higher in the roots than in the stem, whereas no gold was found in the leaves. The high amount of gold in the leaves of the leaf supply and in the roots of the root supply could be explained by the particles that were still present on the surface of the tree parts, even though they were throughoutly washed. But however, the amount of gold in the stem is higher in the leaf supply. And with regard to the surface charge, the concentration of variously charged gold nanoparticles were significantly higher between the root and the leaf supply, and also among the different tissues. We got to some conclusions, and we can see that the nanoparticles were uptaken both by roots and leaves and transported to different compartments of the trees, but also the ancient pathways influenced the nanoparticle transport. And it seemed, just like in the study of Cucozza et al., that the nanoparticles move faster and for more long distance from the leaves than through the phloem to the xylem, so the wood, and farther are dispersed throughout the plant system, including to the roots. There is, yes, high variability among treatment and species, and we also saw species-specific gold uptake and transport, as more gold was found in beech than in Scots pine. Now, to go back to our initial question, yes, trees can be used in monitoring atmospheric fine particulate, and that is because it was proven or observed that vegetation surfaces can serve as a sink for atmospheric pollutants. And also, tree ring records of trace elements can be used in reconstructing the history of pollution in a specific region. And as a take-home message, the selection of suitable tree species, native and non-native, in an urban area is a valuable measure for controlling the particulate matter and the nanoparticle pollution. Thank you very much for your attention.